Section 8.3, we're actually going to only address one of these objectives today. We're going to be solving equations involving trig functions. So let me give you some samples. And the thing that makes these problems a little bit different is that you're really going to be looking out for multiple answers, because according to the directions, we're going to be solving each equation on the interval from 0 to 2 pi. So what that really means is if you travel all the way around the unit circle, there are, for example, two different places where cosine is negative 1/2. That occurs here at 2 pi over 3, and it also occurs down here at 4 pi over 3. So there's an example of how you could come up with two different answers when you travel the interval from 0 to 2 pi, which is really another way of saying all the way around the unit circle. So let me show you how you can come up with these answers. So number 11, these problems are really pretty simple. We need to isolate the trig function, in this case sine. So just think how you would typically isolate a variable. You would subtract 3 first. You would then divide by 2. And then you're thinking this way too, you're solving for theta. So the inverse of sine on both sides. So I'll show it in this way to show my work. So think of those canceling each other, and we're left with theta. And so now you're doing the inverse. What angle gives you sine negative 1/2? And remember, for inverse sine, that comes from the right half of the unit circle. So what angle has sine negative 1/2 in this interval from 0 to 2 pi? Well, I see it definitely here, 11 pi over 6. So your thinking here is a little bit different than what we did earlier. You're going to consider basically this entire interval from 0 to 2 pi. So look at the entire unit circle and find angles where the sine or the y coordinate would be negative 1/2. So just call it out to me when you see it. Well, let's do it in radians, and it's got to be negative 1/2. Okay, we got 11 pi over 6. We mentioned that one earlier, and then there's another one, 7 pi over 6. So it's actually going to be two different answers. So the key here is this. We're now opening up our possible answers to all of the places on the unit circle where this is true, where the y coordinate of a particular angle is negative 1/2. So most of these are going to have at least two answers. Some will have 3 or 4. Okay, let's take a look at another example. So once again, you're working toward isolating theta. So my first move here is going to be divide by 4 on both sides. And now think square root of both sides, and that just makes cosine theta. And the square root of 4, remember that's, or square root of 1/4. It's not squared, it's the square root of. All right, so once again, we are trying to find the angles actually where cosine would be positive 1/2 and also where it would be negative 1/2. So all the way around the unit circle, let's identify angles where the x-coordinate is either positive or negative 1/2. So Shelby, give me one of those. Pi over 3. And John, give me another one. Two pi over 3. Ruthie. 4 pi over 3. And Lily. 5 pi over 3. Did we get them all? Any questions about number 13? Okay, let's try number 15. Same idea. We're going to add 1 to both sides first. We're going to divide by 2. Square root of both sides. And don't forget plus minus. So let's think of the square root of 1/2. Okay, I'm going to come over here and do a little work. And then let's rationalize that. What would that be in rationalized form? Because really it means the square root of 1 over the square root of 2. You could think of it that way. So when rationalized, it would be plus minus. Very good. And so now to isolate theta, think inverse sine. And let's come up with all of the angles on the unit circle that would have y coordinate either positive root 2 over 2 or negative root 2 over 2. So let's get started. Ruthie, give me one of those. Either one of these. Root 2 over 2, pi over 4, okay. And Emma, 3 pi over 4. Stacy, 5 pi over 4. And then back to Shelby. Good. Any questions? So these problems, you can see they're pretty easy. We just have to isolate theta and then look for all of the occurrences of either x or y on the unit circle. These problems are a little bit different. And I'm just showing you this graph. You don't have to graph these. I'm going to show you a way to come up with the answer without having to graph. But I wanted to show you how the graph does show where those multiple answers are going to come from. When you see problems, these equations where there's a number being multiplied times theta, if you notice, that hasn't happened yet. I haven't had a number in front of theta with any of these previous examples. So when there's a number in front of theta, the process changes quite a bit. And here's why. Remember when we graphed the sine function and we came up with the period 2 pi over whatever was in front of theta? In this case it would be 3. And then we came up with the interval. Remember how we came up with the graph interval? We just took that number divided by 4, which is another way of saying times 1/4. So what this says is if I drew the line y equals -1, which is really what this is saying, where would this graph touch the line y equals -1? And it touches here at pi over 2, it touches here at 7 pi over 6, and it touches here at 11 pi over 6. Okay, so keep those answers in mind. Here's how we're going to come up with those same answers, but we're not going to use graphing. We're going to solve an equation, or sometimes two equations. So let me show you how this works. The first thing we're going to do is we're going to do inverse sine on both sides. Okay, so I'm going to show my work. I'm going to isolate, make this just become 3 times theta. Okay, and what that does is, again, it makes these trig functions cancel each other, and I'm left with 3 theta. And now look on the unit circle and give me the radian measure of sine -1. What angle has y coordinate -1? Anybody got that? Lily, what is that? 3 pi over 2. Okay? Now this is where these problems get a little bit different. There is no other place on the unit circle where the y coordinate is -1. And so to help me come up with any other possible answers, I'm going to add this expression, this factor, this term, and it's always going to be like this. So this is an always step when you do these problems. This represents, k just represents some number. And when I put the number in for k, it's going to help me basically find any other answers that may exist in this interval between 0 and 2 pi. Okay, so this is a very necessary step whenever there's a number being multiplied times theta. And now let's isolate theta. And I do that by dividing everything by 3. Okay, so, or you can think multiplying by 1/3. So John, if I multiply by 1/3 all the way across here, what would this become? 3 pi over 2 times 1/3. Okay, and let's reduce that. Pi over 2. Everybody see that? It started off at 3 pi over 6, which is 1 pi over 2. And now don't forget, you have to multiply this by 1/3 also. And Stacy, what does that become? Okay, so now the work begins to try to find all of the possible answers for theta. We're going to start plugging numbers in for k starting at 0. Okay, so let's just imagine that k is 0. If I let k be 0 and I simplify the right side of this to come up with theta, what do I get? Well, this becomes 0. If I'm multiplying by 0, this whole fraction becomes 0. So pi over 2 plus 0 is pi over 2. Okay, so what I'm interested in, after I plug numbers in for k, do these results fall in the range, the interval from 0 to 2 pi? So obviously pi over 2 fits. So it's going to be one of my answers. Okay? Well, let's see if there are other answers. Let's let k be 1. So if I let k be 1, I've got pi over 2 plus 2 pi over 3, and I've got to come up with a common denominator before I can add those together. What is that common denominator? Six. Okay, so let's just do some common denominator work here. What will this numerator be? 2 goes into 6 3 times. 3 times pi is 3 pi. 3 goes into 6 2 times. 2 times 2 is 4 pi. When I add those together, I get what? Okay, so now the question becomes, is 7 pi over 6 in this? Well, if you have to think about it as a mixed number, that's 1 1/6 pi. Is 1 1/6 less than 2? Yes, so this is another answer. That's going to be true for all of them. It's in the directions. Yeah, the directions read like that. And it actually won't be or equal to 2 pi, just less than. Okay, well, let's see if there's another answer. So what do you think I'm going to do now? I've let k be 0. I've let k be 1. Well, let's see if k can be 2. And we still get an answer that fits. So over here, I'll do the k equals 2. All right, so pi over 2. If k is 2, that makes 2 times 2 is 4 pi over 3. Using that same common denominator, it's still going to be 3 pi over 6. What will this numerator be? 3 goes into 6 twice. 2 times 4 is 8. Okay, so that's 11 pi over 6. Does that work? 6 goes into 11. So I'm still less than 2. So 11 pi over 6 is also going to be an answer. Okay, and so now you can pretty much tell at this point I'm real close to 2 pi. If this were 12, I would be at 2 pi. So at this point, I know that if I let k be 3, I'm going to be over the limit. But you could go ahead and do it just in case if you wanted to be sure. So I've come up with all of the answers that fall within this area. Pi over 2, 7 pi over 6, and 11 pi over 6. So that's the process, and this is the only time you have to do this process is when there's a number, a factor multiplied times the angle theta. So we might need to practice those a few times. Let's try another one. So let's work through number 19. First thing I'm going to do, of course, is I'm going to do inverse cosine on both sides, trying to get theta by itself. So I'll just show that. So it's like inverse cosine and cosine will cancel each other. And I'm showing that on both sides. All right, so this gets me 2 theta, 2 times theta. And let's go ahead and figure out where on the unit circle, what angle has x coordinate negative 1/2. Well, that occurs here at 4 pi over 3. And we're going to add that extra step so that we can get additional, whenever a number is multiplied times theta, you need this additional term to help you find all of the possible answers in the area that we talked about earlier between 0 and 2 pi. So this is kind of like another term that helps us find all of those potential answers. Okay, well, not only do we have an angle with x coordinate negative 1/2 at 4 pi over 3, but we also have it here at 2 pi over 3. So in this case, I'm going to have 2 different equations to plug numbers in for k. And now let's just go ahead and get theta by itself, dividing by 2 or multiplying by 1/2. If we multiply by 1/2, that makes 4/6, and 4 over 6 makes 2/3, so 2 pi over 3 plus, and then don't forget over here you also have to multiply, got to multiply by 1/2 or divide by 2. That's going to make k times pi. And then same thing over here, dividing by 2, multiplying by 1/2, that makes 2/6, which is pi over 3. And also plus k pi. Okay, so now we're going to do our inputs for k. We'll start over here with this one. If we let k be 0, let's put a little column here, k will be 0, then obviously this whole term becomes 0, and I'm left with, excuse me, 2 pi over 3. Okay, and if I let k be 1, then I'm going to have 2 pi over 3 plus 1 times pi, which is obviously just pi. All right, so we need a common denominator, which is going to be 3. 2 pi over 3 plus, this is going to be 3 pi over 3. And if I add these together, you get 5 pi over 3. And that does fall within this acceptable area. It's on the unit circle, and already provided these answers ahead of time. So that's how we got 2 of our answers, 2 pi over 3 and 5 pi over 3. Now, just for sake of time, if I did go with k equals 2, I'm going to get a result that falls outside of this area. It's going to be larger than 2 pi. So I'm not going to accept that result. So using this equation, where we found 4 pi over 3 as the x-coordinate for the angle at -1/2, we got these 2 results. Okay, well now we're going to jump over here and use this equation, because remember there's 2 different angles that have this x-coordinate. So again, start at k equals 0, and if you do, if k is 0, this whole term becomes 0, and that's how we got pi over 3 as one of our answers. Okay, so k is 0, the result is pi over 3. If k is 1, okay, so again, if k is 1, then we're going to be adding pi over 3 plus 1 times pi, and putting it in terms of a common denominator would be 3 pi over 3. And when you add these together, you get 4 pi over 3. And that's where this answer came from. And that does fall within this acceptable area. If we went up to k is 2, we're going to get a result that falls outside. It's going to be a multiple of pi that's bigger than 2 pi. Okay, so that is the process, and that's only necessary when we have a number in front of theta being multiplied times theta. That's the only time that you've got to go through this process of adding this additional term to k pi and then using numbers to substitute in for k starting at 0. Okay, so let's try one more. Number 21 was the last one that we actually worked in your notes. So let's see, secant, this is saying secant of this is equal to -2. Well, think of it this way. Secant is the inverse or the reciprocal of cosine. So if I took this -2 and I flipped it over, which another way of saying the reciprocal, I would have -1/2. So think of it this way. Instead of secant -2, think cosine -1/2. Okay, and so to set up my equations, I'm going to say 3 theta over 2, and let's figure out now what are the angles that have x-coordinate -1/2. And I think we just looked at that example in the previous problem. Same ones. We had 2 pi over 3 and 4 pi over 3. And we're going to add this additional term. All right, so that'll be one equation that I work out of, and we're going to isolate theta, multiplying by 2/3 all the way across. So 2 pi over 3 times 2/3 would be 4 pi over 9. And this would be 4k pi over 3. Okay, so we'll start inputting numbers for k, and again, we're trying to get results that match this area. All right, So let's jump over here and we'll set up another equation because there are two different places where cosine is negative 1/2. All right, isolating theta gets me, I'm multiplying by 2/3. That would be 8 pi over 9, just 4 pi over 3 times 2/3. And this times 2/3 would be 4k pi over 3. Okay, now we start doing our inputs starting at 0, and hopefully we can maybe do some mental math here for some of these. If I let k be 0, that obviously makes this entire term drop out, and the result's going to be 4 pi over 9. And that fits in the area from 0 to 2 pi. All right, let's see if we'll just come down here since we're not going to do number 23. Let's let k be 1. So 4 pi over 9 plus 4 times 1, which is 4 pi over 3, changing to a common denominator. Obviously this one doesn't change, but this becomes 12 pi. 3 goes into 9 3 times. 3 times 4 is 12. And I get 16 pi over 9. Okay, so think of this as a mixed number. Obviously 9 goes into 16 one time with a fraction. Okay, and so obviously that is less than 2, so this is acceptable. Okay, so to go along with 4 pi over 9, I've got 16 pi over 9. If I did go up to k equals 3, I'm going to be over this 2 pi right side extreme. So I'm only going to get 2 answers from this left equation. All right, so far I've got 4 pi over 9, 16 pi over 9. So now let's jump over and we'll do the same thing here. If I let k be 0, then I get 8 pi over 9, which works. If I let k be 1, let's see what that is. So 8 pi over 9. And let's just go ahead and do mentally 3 goes into 9 3 times. 3 times 4 is 12 pi over 9. That gives me 20 pi over 9. Well, 9 goes into 20 2 times plus a little bit more, which is over 2 pi. So I can't accept this answer, but I can accept this one. So this answer for number 21 has 3 answers to it. The final answer is going to be 4 pi over 9, 8 pi over 9, and 16 pi over 9. And so that's how it works. So only when, as you can tell, I'm multiplying something times theta, that's the only time that I'm going to need to go through this extra process. For problems like number 23, you just work on getting theta by itself. Okay, so I'll just run through this one real fast because these are quite a bit easier. So I start by subtracting 1 from both sides. Then I divide 2 on both sides. And now I do, to get theta by itself, I use the reciprocal function of sine, which is inverse sine. So now this says what angle has y coordinate negative 1/2? Well, there's actually more than one. I have that happen right here at 7 pi over 6. And that also happens over here at 11 pi over 6. And obviously both of those fall within the 0 to 2 pi because they're both on the unit circle. Okay, so hopefully that helps you with the homework assignment. And the assignment that we're going to have for next time will be here. And if you have any questions, let me know.